Hi everybody. In this video I want to go over briefly some vector representations and vector notation that we'll be using in this course. First, I want to clarify that if we have the x component, the y component, and the z component of a vector, we have all the information contained in that vector, or we could construct all the related information. So that tells us everything that we need to know to calculate everything else we need to know about that vector. Now, we could put all that in one single expression. For example, I could write the vector A as the x component of vector A multiplied by a unit vector in the x direction, which I'll call x hat, plus the y component of vector A multiplied by a unit vector in the y direction, plus the z component of the vector A multiplied by a unit vector in the z direction. So x hat, y hat, and z hat are representing unit vectors in the x, y, and z directions, respectively. I'll use those symbols interchangeable with I hat, j hat, and k hat. So this is also a unit vector in the x direction. This is another representation for a unit vector in the y direction. This is another way to represent the unit vector in the z direction. These two sets of symbols are used interchangeably. This is preferred in some books. These are preferred in other books. I will use both. All right, another way we could represent the vector A, we could write the vector A in terms of its magnitude, and I'll have more to say about magnitude in a moment, multiplied by a unit vector in the direction of vector A. I'll talk more about constructing unit vectors in another video. So if you see, anytime you see a caret symbol over a vector, it means a unit vector in the direction of the original vector with the vector symbol. All right. I want to point out there are other ways to represent vectors. Other courses or books may represent the component information in a column. This is just another scheme for doing calculations or writing equations with the x, y, and z components of a vector all at once, similar to using this type of notation. For reasons that we'll see in the next few courses, this type of notation is particularly useful for three-dimensional calculations in electricity and magnetism. All right, finally, I want to point out that it's very, very important to remember the difference between a vector and its magnitude. So don't conflate the vector A with its magnitude. The magnitude of a vector is only part of the information of a vector. So if you see, say, an A without an arrow over it, that represents the magnitude of the vector A. There's another way to represent the magnitude of vector A. I could put the full vector A between absolute value symbols. That doesn't mean absolute value of the vector A. That phrase has no meaning. When you see the vector A between absolute value symbols, this whole thing taken together is another way to say magnitude of the vector A, just like writing the A without the arrow symbol over it. Remember, magnitudes of vectors are always positive. So we just have to keep in mind the difference between the magnitude of a vector and the vector whose magnitude it's representing. In 2 dimensions, we have another representation available to us. We could represent the two-dimensional vector as a magnitude and a direction specified appropriately in a two-dimensional coordinate plane. For example, 30 degrees counterclockwise from the positive x-axis. Okay, so that's my overview of representations of vectors and the notation that we'll be using in this course. Thanks for watching.